If Pandas is your only tool, you're not landing your next job in data. Pandas is great for getting started, but the second you step into a corporate pipeline, it starts breaking down. Today, I'm going to show you 4 things Polars can do that Pandas simply can't, and how each one not only saves companies money, but puts you in line for that next promotion. Stick with me because by the end, you'll have code examples, ROI proof, interview prep, and even a free career cheat sheet complete with video resources for additional knowledge. Think of Pandas like driving a dependable little sedan. It'll get you to the grocery store, no problem. But try hauling a trailer or driving cross country and you're going to struggle. Polars is like upgrading to a turbocharged SUV with towing power, or in my case, a Jeep Wrangler. Same concept of driving, but built for bigger, heavier, real-world jobs. And here's the reality. Pandas will happily eat your memory alive once you pass a few hundred megabytes. I've seen entire production pipelines crash because someone tried to use Pandas on a 10 gig CSV file. Polars was built for modern workloads. It's parallel, optimized, and runs on Arrow, which has Parquet built into it. So, what exactly does Polars give you that Pandas never will? And how does learning it translate directly into business ROI and career acceleration? Let's break it down. Feature number 1, lazy evaluation. So here's a code. With Polars, the query doesn't run until you call that collect statement. This means less wasted memory, faster pipelines, and lower infrastructure costs. From a career perspective, this mirrors Spark, dbt, and Databricks pipelines. When you understand lazy execution, you're showing hiring managers you think like an enterprise data engineer. The pitfall that people run into is debugging is harder because not everything executes all at once. It waits till the end. So you don't always see errors immediately like you do when you're using Pandas. Now, when is Pandas better? Because there are times. Quick exploratory analysis where you want instant results and instant feedback. Again, for exploration, for testing, Pandas can be okay. But for real-world production environments, that is handling large files and big data, you're going to need to upgrade. So, for your exercise here, load a 1 gig CSV with scan_CSV in Polars. Then compare that runtime to read CSV from Pandas. See and document what those efficiency differences are. Now, your interview question here. Explain lazy evaluation and why it matters in data pipelines. And your resource is a Coursera course, Data Engineering with Rust. Check it out. All right, feature number 2, parallelization. Big word, could be a tongue twister. Here's what it looks like. Now, unlike Pandas, Polars uses multiple cores by default. Same machine, but faster output and lower cloud bills. From a career perspective, if you can take a pipeline that runs 4 hours in Pandas and bring it down to 30 minutes in Polars, leadership is going to lean in and take notice. That is promotion material right there and something that you need to add to your resume. Your pitfall here is parallelism has some overhead. For really small data sets, there's something called the small file problem. And you actually end up waiting longer for threads to spin up than it would have just taken for Pandas to just run the job initially. So Pandas better. Tiny data frames, a few megabytes or less, where simplicity beats complexity. Your exercise here, benchmark the same aggregation in Pandas and Polars on an 8-core machine. So probably your laptop would work. And do it with a small file and do it with a larger file. Document and watch the differences. You're going to notice that with a smaller file, Pandas probably performs better. But with the larger file, Polars is going to be incredibly faster. Your interview question here, how does Polars achieve parallelism where Pandas cannot? And your resource is another Coursera course, Concurrent and Parallel Programming in Python. All right, feature number 3, query optimization. Here's what that code looks like. Polars builds a query plan, prunes unused columns, and pushes filters down. That means less I/O and less cost. Career-wise, this is SQL-style optimization inside of Python. If you can explain predicate pushdown and column pruning, you stand out from people who just write scripts. The pitfall here, optimizations can be a black box. If you don't understand what's going on, you might assume that your query is efficient when really it's not. And when is Pandas smaller? Small one-off transformations where you want to see every step clearly and keep things transparent. Your exercise is write a Polars query that only reads the necessary columns from the Parquet file. Now, for your interview question, tell me, what's predicate pushdown and why does it save money? And another Coursera course, Managing Big Data in Clusters and Cloud Storage. Check it out. Feature number 4, Arrow and Parquet integration. So here's what that code looks like using PyArrow. Now, Polars natively integrates with Arrow and Parquet. That means zero copy compatibility with Spark, BigQuery, Databricks, no conversions, no wasted compute. Career-wise, Arrow is the backbone of a lot of modern data systems. Knowing it gives you enterprise-level credibility in your interviews. The pitfall that some engineers fall into is that there are some extra dependencies. Arrow and Parquet require version alignment, and that can complicate some environments. When Pandas is better here is when you have simple CSV or Excel workflows, especially for end users who don't need Arrow or Parquet. Your exercise, take a dataset in Arrow, load it into Polars, save it as a Parquet file, and open it in Spark. See what happens, watch that efficiency run, and you'll find that it's a whole lot smoother than what you've been using in Pandas and Polars. Your interview question here is, why is Arrow important in modern data pipelines? Let me know down in the comments what your answer would be to that. Now, your Coursera course here is Databricks Lakehouse Fundamentals. Be sure to check that out. Again, all my affiliate links are down in the comments. Here, you are looking at lazy evaluation, parallelism, query optimization, Arrow and Parquet integration. These aren't just technical upgrades, they are career accelerators that move you from your mid-level careers into your senior careers quickly. They save companies thousands, cut delivery timelines in half, and prove that you are ready for bigger responsibilities. Here's the trap that some engineers fall into. Don't treat Polars like just a faster Pandas. Every feature has trade-offs. Lazy evaluation can make debugging harder. Parallelism can be slower on small jobs. Query optimization can hide some inefficiencies that are going on there. Arrow integration can add dependency headaches. So when is Pandas still better? For quick EDA, lightweight datasets, one-off scripts, or simple CSV work. The real skill is knowing when to reach for Polars and when Pandas is actually still the right choice. So, you want to take this further? I put together a free one-pager, the Pandas vs. Polars career cheat sheet. Check it out. Link is down in the comments. It is got all the code exercises, interview questions, and resources that we covered today. And if you think you're ready, click here to jump into Databricks and take your career from zero to hero.